Hess law. First we will understand it with an example, right? How we can define Hess law, I will be talking about just after that. So suppose we have reactants and we can produce from these reactants some products. Okay, now there are two ways. This reaction can take place in one step, and there is possibility that first we convert it to something else, then to something else, and then we get the final product. And in all these three cases, here in this particular case I am talking about, say there are three steps we can get B from A, B. Remember, A is combination of reactants, B is combination of products. And the enthalpy change in these three, say in first one it is delta H1, second one delta H2, and delta H3 in the third one. Now if we can produce same products B from A in single step, and the enthalpy change is delta H of the reaction, delta RH means delta H of the reaction, then in that case this particular enthalpy will be sum of all these three. That's Hess law. So delta RH will be delta RH1 plus delta RH2 plus delta RH3. If we have more than 3 steps, it will be delta RH4 as well. If we have only 2 steps, it will be up to delta RH2. So how we can define it? We can say if a reaction takes place in several steps, then its standard reaction enthalpy is the sum of the standard enthalpies of intermediate reactions into which the overall reaction may be divided at the same temperature. Conditions are not changed, temperature is same, because otherwise delta RH will be different. So temperature is same. Having said so, students are sometimes confused, so you need to be very cautious here. When I am saying I am converting A to B in single step, and I am converting A to C, C to D, and D to B, it does not necessarily mean that I will convert A to C first. No. Okay, what actually I mean that, suppose I have 3 reactions, 1, 2, 3 reactions. Okay, if I add these 3 reactions, okay, and I get this reaction, then the sum of enthalpies of these 3 reactions will be equal to the enthalpy of the main reaction. You will be able to understand it with an example. So here is the example. Okay. Consider the following reactions. These 2 reactions are given and their reaction enthalpies are given. Means delta RH1 is given, then delta RH2 is given. These 2 are given. Question is, find the enthalpy of following reaction. Now our task as per Hess law is, if by using these 2 reactions, if we add these 2 reactions for example, and if we get the third one, we can get the answer. In that case we will add the enthalpies of these 2 reactions. However, in most of the cases the question will not be that straightforward. In few cases you will have to reverse the reactions, the given reactions. Okay, so in few cases what will happen? You will have to reverse the reaction, or you will have to multiply by a coefficient. Okay, so suppose here it is 2 CO2, then you might need to multiply the whole reaction, say this whole reaction by 2. Okay. This one is relatively simple. And how do you get the final equation, the required equation? How do you get from the given equations? There is a trick. Okay, the trick is, you see what I need on the right hand side. I need carbon monoxide. Okay, and do you have carbon monoxide? Yes, I have carbon monoxide, but it is on left hand side. I need it on right hand side. It means I need to reverse this reaction. I need to reverse the reaction. Reactants will be products and products will be reactants here. And obviously when we do so, the sign of delta R will change. So how can we get this particular reaction from these 2? I am starting it now. We need carbon on left hand side. We have carbon on left hand side. We need 1 mole of carbon. We have 1 mole of carbon. It means it is straightforward. The first reaction has to be used as it is. We need carbon graphite on left hand side. It is there on left hand side. we need carbon monoxide on right hand side, it is on left hand side. It means second one has to be subtracted. Addition after reversal is actually subtraction. So the way is you need to subtract it. Why? Because it is actually CO2 gives CO plus half O2. I have reversed this reaction, okay. So here delta H of this reaction will be, instead of negative, it will be positive 283.0 kilojoules per mole. So either I say I am adding this one. So if you use this reaction, you need carbon monoxide on right hand side. Carbon monoxide is on right hand side. So it means you need to add this one. So in this case, if you add this one, that is minus 393.5, and add this one, okay, not this one, because you are using now this reverse reaction, it will be plus 283.0. But if I write it 1 minus 2, it will give you same answer. It will be minus 393.5 minus, if you subtract this one, that is minus 283.0, it will give you minus 393.5, and minus into minus will give you plus 283.0. So it will give you same thing, whether you say reverse and add or just subtract, it is same thing. Now you need to consider whether you actually get the final reaction or not. So what we are doing first one as it is. So write first one as it is, C graphite plus oxygen gas as CO2, and reverse this one because you will be adding after reversing it. So reverse it. CO2 gives us carbon monoxide and half O2. Now if you add these two, this is simple mathematics addition here. CO2 on right hand side, CO2 on left hand side will get cancelled. Okay, so you have carbon only here. Oxygen on left hand side you have 1, and on right hand side you have half. It means 1 minus half will be half O2. And now on right hand side you have only CO. So you actually get the required equation if you add these two. Okay, so delta H of this reaction, delta RH1 is given minus 393.5 kilojoules per mole. Units I am not writing, you should write. And here delta RH, I am saying it 3, okay, because 2 we have already considered for this one. For example, it will be reverse of minus 283, that is plus 283.0. And the enthalpy of this reaction, delta RH, will be sum of these two steps, that is delta RH1 plus delta RH3. So it will be minus 393.5 plus 283.0 kilojoules per mole. When you add this one, obviously minus is greater, so answer will be negative. Minus 110.5 kilojoules per mole will be the answer. Now next one. The combustion of 1 mole of benzene takes place at 298 Kelvin and 1 atm. After combustion, CO2 gas and H2O liquid are produced and this much heat is liberated. If it is liberated, it has to be negative. So you should remember the sign you will be using here will be negative. Calculate the standard enthalpy of formation of benzene. Standard enthalpy of formation of CO2 and H2O are given. Now in such cases, if you have to do it with Hess law, yes, you can do it with Hess law. Otherwise, if it is not mentioned that you have to do it by Hess law, you can use it by the formula that the reaction enthalpy is given by sum of the enthalpies of formation of products. Okay? Enthalpies of formation of products, delta H of products multiplied by their stoichiometric coefficients minus sum of enthalpies of reactants multiplied by their stoichiometric coefficient. You know that formula. So this question can be done by using that formula, and I suggest that if it is not mentioned, you use this formula. It will be easier. But suppose it is asked to be done by Hess law specifically, then we can do it by Hess law as well. So what we will do, we will first form the equations from the given information. The information is that combustion of 1 mole of benzene means C6H6 will react with oxygen, and you know the combustion reaction, generic combustion reaction, CXHY plus X plus Y by 4 O2 gives us XCO2 plus Y by 2 H2. In this particular case, you will write it for C6H6 means X is 1, Y is 1, and delta H of this reaction will be minus 3267. Then we have to calculate the enthalpy of formation of benzene, means 6C plus 3H2 gives us C6H6. Remember, enthalpy of formation will always be from the elements. Carbon exists as C, hydrogen exists as H2. So that's why we have written it 6C plus 3H2 gives us C6H6. So this delta H we have to calculate. Then something else is also given. Standard enthalpy of formation of CO2 is also given. So C plus O2 gives you CO2 1 mole. This enthalpy is given. Then enthalpy of formation of H2O is given, means H2 plus half O2 gives you H2O. Because we are talking about enthalpy of formation, remember it has to be only 1 mole formed. So here you will not write 2H2 plus O2 gives you 2H2O. You will write H2 plus half O2 gives you just 1 mole of H2O. On right hand side it has to be 1 mole produced. Here also delta H is given. All these delta H are given. So from the given equations we have to form this equation. That's it. So first we will form the equation for combustion of benzene. The reaction for combustion of benzene using the generic form will be this one, and delta H will be minus 3267, which is given. Then enthalpy of formation of carbon dioxide, this is the reaction we have talked about, enthalpy is given. Then enthalpy of formation of water, this will be the reaction, value of delta FH given, and this is the required one. So by using these 3 reactions shown in blue color, we have to form the yellow colored equation. Okay. Again apply the same rule. We need carbon on left hand side and we have carbon on left hand side, but we need 6 carbons. It means we will multiply this whole reaction by 6. So it will be 6C plus 6 O2 gives us 6 CO2, and delta FH of this reaction you have to multiply by 6. So the value of delta FH now will be 6 times minus 393.5. Then we need 3H2 on left hand side, hydrogen we need on left hand side. We will find in which reaction we have hydrogen. We have hydrogen here on left hand side. So it is on left hand side, we don't need to do anything, but we need 3 moles of hydrogen. It means we will multiply this whole equation by 3, and we will have to multiply the delta FH also by 3. We need C6H6 on right hand side. C6H6 here is on left hand side. It is just 1 mole. We need 1 mole. It is 1 mole, but it is on opposite side. So we will have to reverse it. Okay. This one we need to multiply by minus 1. Reversal is what? Reversal is just multiply by minus 1. It means delta H of this one you need to multiply by minus 1. Now add all and you will get the value of delta FH. We have modified the given equations as per the requirement. After that you just need to add these. So delta RH or delta FH of required reaction will be first one you have to multiply by minus 1. So it means this multiplied by minus 1. Okay. So it will be minus delta CH0 there. Okay. Say this one is 1 here. I am writing 1 here and I am writing 2 here. Okay. Just to differentiate these. So multiply this given enthalpy by minus 1. Then second case, multiply this given enthalpy by 6 and add What is this enthalpy? 6 times minus 393.5. The enthalpy is minus 393.5 multiplied by 6. And then whatever is the enthalpy here, so I'm not writing 393.5, rather first write delta FH1 naught. Okay, then add 3 times what? Delta FH2 naught. Okay, now substitute the values. When you substitute the value minus, and delta CH is given minus 3267. All are in kilojoules, so we don't need to change the units. Okay, then plus 6 times delta FH1 is minus 393.5 kilojoules per mole, plus 3 times delta FH2 is minus 285.83 kilojoules per mole. Substitute the values, solve it, and you will get the answer. Okay, when you solve it, you will get 48.51 kilojoules per mole. That will be the answer.